Hi everyone. So in this video, I'm going to talk more about the other kind of important concept that you're going to need to do some of the harder rules. And that concept is merging. So if you're familiar with SQL and the concept of joining, it's a very similar thing, just in pandas. But all the concepts and all the kind of names and jargon will be really similar. So if you have that background in SQL, you'll probably find this quite easy to follow. If you don't, no worries, I'll try and explain it as well. It'll probably be helpful to read some of the supplementary material because I'll try and link out to most likely better explanations. But overall, it's not too hard a concept to grasp, and this will let you do all those pesky rules that require linking up multiple tables, linking back to last year's tables, this kind of stuff. So, in terms of doing a merge, the reason that you might do it is to link two tables. And here in this REPL, I've got again 3 synthetic files, and I remind you again that if you want to follow this, that's fine, but make sure you're using synthetic files. I think I have provided some to you guys already. I can provide some more as well. Don't upload real 903 files to Replit because that'll be an information governance issue. However, that being said, so these are synthetic files, but the data has some structure. So I can sort of print these out and have a look at what they look like. And you can see we've got kind of a usual header file here, and we've got a UASC file, which is going to be a lot shorter because that only has a few children in. And the idea of merging is very similar to joining in SQL. Is that wouldn't it be good to have one table with entries for all the children? So for example, say if you had a rule which said every child who is an asylum seeker also needs to have a date of birth. I mean, obviously we check that anyway, but in order to do that, you would need to have access both to the date of birth for that child and to the asylum status. So basically, whether or not they're present in this data here. So the simplest way to do that, I mean, there's plenty of ways that you could code it with your current knowledge. You could sort of write a for loop over every child, look them up by doing indexing, and come at it that way. But it won't be very efficient, which is a bit of a problem. It'll be much longer to code, kind of harder to maintain, and kind of a bit hard to follow as well. So getting some familiarity with merging will give you a lot more power in this domain. So let's have a look at thinking about that problem. So let's have a look at what the merge table might look like. So to merge, you just take one data frame and call the merge method, and then call that with the data frame that you want to merge on, and give an argument for the key that you want to merge by. So in this case, the key will be matching on child, and I'll just print that out. So if we have a look at the output from this, so you can see a few interesting things have happened here straight away. And in fact, what I'll do as well is I will, I'll just give that a name, so just tie this up a little bit. So, but what you're seeing, just so that we can see all the columns as well, because of the way it's printed out, we didn't get to see everything. So there's a few kind of interesting bits to look at here. So we can see that because header and UASC had some similar columns, and in fact what I'll do is I'll print out both of those as well, just that it's very clear what I'm talking about. So you can see that these had child, sex, date of birth, ethnic, UPN, mother, MCDOB, and again in the UASC you've got child, sex, date of birth again in DUC. So what's happened here is we've actually got child, which is the same for both because that's what we told it to merge on. Then it's got sex X DOBX and sex Y DOBY in the merge table, as well as ethnic, UPN, mother, MCDOB, and DUC from the asylum seeker table. So this is going to be the default behavior for when you try and merge two things that have different names. Is it will name them _x _y. You can have control over this, so maybe it'd be better often, I think, for our purposes, to maybe have them named after what they are. So _header _UASC, and if I run that again, You'll see that now the columns are called, the data itself is kind of printed out in a bad way here, but you can see the columns called sex underscore header, DOB underscore header, sex underscore UASC, DOB underscore UASC. So this is helpful for checking things like, is the date of birth in the UASC file the same as the header? I'm not even sure if that's a rule, because I think that should almost always be true based on the way that these CSV exports are created, but you can imagine that kind of validation being needed across the different files. The other thing to notice with this, so is the size of this data frame. So this is 132 rows. And if I just sort of maybe don't print out the whole thing and just print out the shape of these data frames again. So you've got header.shape and UASC.shape. So you can see that the header, the merged data frame has length 132. However, we actually had 2,700 entries in our original data frame and 132 in the UASC. So what's happened here is the equivalent of what you call in SQL is an inner join, and here again you refer to it by the same name. It's an inner merge, where what's happened is any child which is present in only one of the tables but not both has been ignored. This might well be the behavior you want. So for example, if you had a rule here which said for every UASC child you want to check something from the header, then this might make sense, because the UASC table is always going to be a subset of the header table, so you could do an inner merge. But often you might care about whether or not there's data for the children as well. So say if it's the other way around, where you're trying to check for every child in the header, do they have they need to have UASC data, for example, could be a way of doing it. Obviously we know in practice that isn't true, but you would like to see perhaps the children that don't have that data. And the way that you do that is you add another switch to this, which is how equals left. And this can be left, inner, right, or outer. Again, I'll be linking more documentation on merge. If you look at if you just look this up yourself, you can see that there's tons of options. You can have left and right. You have how it's joined, the column it joins on, or alternatively, you can have left on and right on if the columns have different names in both data frames. You can do some joining on the indexes. You can choose whether it's sorted. You can have the suffixes, as I talked about, and you can do some other kind of validation bits too. And all the details on that are here. So if we go back to where we're at here, so if you check here, you can see the default is how equals inner. So if we just put how equals inner here, that shouldn't have any effect on that size of rule 132.10. But if we do how equals left, what's going to happen? Well, we get the left data frame in this case is the one on the left, whereas this is the one on the right, the one in the bracket. So the left is the header. So we should see that this new data frame then retains an entry for every entry in the header. And yep, we see now that now that we've done the left join, then maybe it's helpful to kind of print that out to have a look. We do see this kind of larger length for that data frame. You can see 2675 rows and 10 columns, and you can see there's quite a few here where sex UASC is NaN and DOB UASC is NaN, because there's not data for those. So an interesting sort of wrinkle and a very common pattern that you're going to have to use when you're working with these merge tables. So for us, we mainly care about the indexes in the original table. So like if we're trying to index back into the header table, we care about, and if I just kind of get rid of all of this stuff for now, we care about this index, and that's going to be the index that we use when we're returning the error locations, when you're coding the rules for these for this data. So that being said, what happens when you merge here is actually the merge creates a whole new table with a whole new index, and that index data gets lost. In cases like this, where you know that doing a left merge should still be 1-to-1, and should still produce like a data frame with the same length, you can sort of get away with it, but it's probably not good practice. And the reason for that is as follows. So so let's say that if instead we care about the rather than UASC, we care about the episodes table. Let's get rid of these suffixes for now because they're a bit confusing. So if we look at the shape of the header table and the shape of the episodes table, the thing about the episodes, and this is the key thing to think about with this merging, is that there can be many episodes for every child. So when you do this merge, what you're actually doing is you're doing a one-to-many merge. And I think that's the other question you want to be asking yourself, as well as whether you want to do a left or an outer or an inner. So is it one-to-one, in which case the outputs will be the same shape as the inputs? Or is it one-to-many, where, say, you maybe start with one line per child and three episodes per child? What you're going to get then is you're going to get one line per every episode, even doing a left join. So that's going to really kind of affect the outputs, thinking about whether it's like the structure of that. And if I have a look here at what we're looking at here, so this is going to give you an entry for every child together with their episodes. Sorry, I'll print out the data here at the top there. And you can see here, so we get this data frame printout. There's 5,600 episodes, and everything else. However, we know that there's only 2,600 children, and there's 5,050 episodes. So how have we ended up with 5,600 as our overall size? And it's because you get not so in the synthetic data that I've generated. And I think this actually won't be the case in practice, but it's worth it's good for illustration. There's some children in the header file who don't have any episodes, just because of the way that it's synthetically generated. There's a chance that they'll have 0 episodes. So based on this, it looks like there's around probably 2,000 children who've had these 5,000 episodes, plus another 600 children who've had no episodes. So are showing up with NAN for all of this. And I think that's the kind of confusing thing about these one-to-many joins, is that you can end up with a table that's actually bigger than both the input tables. You could even have cases where you have many-to-many mapping. So for example, if you wanted to do child episodes this year versus child episodes last year, and you were joining on child, then every episode in one list would then be linked to every single episode in the other list. That'd be quite a weird thing to be doing for this project. I don't really think we should ever find ourselves doing many-to-many joins. But the key point here is that now this index, which is 5,600 long, doesn't correspond to either of these. So how do you go about tracking this back to, let's say, the header file? The way you do that is you add a extra column to the header to tell you what the original index was. And there's a shortcut to doing that. So what you can do is you can say header equals header.resetIndex. And when you call this, it'll provide an extra column, which is literally called index, but it's a column rather than the index, which is a little bit confusing, that will allow you to read off that index. You can see here, we've got this new column, and I can maybe just print out the header file as well to give you a sense of what the interim step looks like here. So the header file comes in, it's now got a copy of its index stored in this index column. So then when you go on to merge that with the episodes, that index is preserved. And then if we say, right, okay, so now I want to find the index of all children that have, at least one episode with legal status v3, let's say. So then I can say, so for my merge df legal status equals v3. I think I've just got my brackets around there. Then, so we can see here, we've selected down to about 400 rows that have that legal status. And we've got the indexes here, but obviously some of them are repeated because some children might have more than one episode with legal status v3. So then to get the original index locations, we would just take out that index column. Again, noting here, I haven't done dot index because that would refer to this column. I've done the lookup on index, which refers to this column, and then taken the unique values. And what you get is you get a list of all the locations in the original child data frame where this is true. And this kind of index tracking pattern is something that you'll probably find yourself doing a ton when you're doing this kind of work. So that's sort of overview. Again, I'm gonna try and go through some rules, and we'll see what we can do in terms of kind of pointing in the right direction of how you might solve something. So the first rule I was going to talk through here is one like this. So there's lots of rules that all have a very similar flavour. They say if the current year this thing is true, then in the last year it should be true too. This particular one is UASC, but you can also have them for date of birth, for anything else. Obviously here I don't have this year and last year data, though it's not too difficult for me to get that kind of synthetically. However, in the actual code, you do have it. It's not super well documented. I'll definitely be adding that to the materials for the harder session. But basically, say for the header, you have this is our kind of usual layout of what we're working with in the rule engine. And then there's also going to be a header underscore last, which if you upload it to the front end will contain last year's data. If you don't upload last year's data, there'll be nothing in there. But then we obviously can't run these validation checks. So in this case, what I'll do is I'll just make a copy of the original header file here and pretend that that's last year's data, which means that everything should be the same. And then the way that you'd approach this is that you might say, right, okay, so we'll take this year's file, we'll merge it with last year's file, we'll merge again on child, because we know that child is the kind of key ID that we're trying to do. So the next question is this going to be a one-to-one merge? Is it going to be one-to-many? Is it going to be many-to-many? I think it's going to be one-to-one, because there should just be one entry per child for each of these entries. Then, do we care about doing so let's say that let's rather than the specific rule that I picked out, let's assume that we're trying to look at something like date of birth. And we want to confirm that the date of birth last year matches the date of birth entered for this year. So what we can then do is if that's what we're looking at, all we care about are children this year that were also present last year. So to save us some time, we can actually do an inner join. And if we print this out, we can have a look and see what this initially looks like and what the sort of first run of merging. Oh, sorry, this should be header last. And I'll just put it on another line for a bit of ease of reading here. And you can see this kind of worked. Again, so this is where those suffixes will come in useful, because here we just got X and Y again. I find it's really difficult to keep track of what's X and what's Y. So I think better practice to have maybe no suffix for this year and underscore last for last year. And when I run that, so we've now got child, sex, DOB, UPN last, all this sort of stuff. Then the last thing that's missing here is, because we're doing an inner join, in this case, because they're the same file, it will still have the same length. But most of the time, you'll end up with something smaller than the two input files, right? Because you're only going to have an entry for things that are in both of them. So like I said before, you want to make sure that you're tracking that index. You can add a reset index just before the merge to make sure that you've got that main index being tracked, and you should see that show up here in the index file, right? And then if I take that sort of merge data frame, then I can just do merge, let's say date of birth, equals merge date of birth last. And that'll be the master I want to work with. In this case, I'm expecting them all to be true, so I can just double check that by calling .all. And this should print out true, and it does. So that's a simple way of kind of checking something like this. And that sort of pattern So you do this. You get the index where so I guess the one part of this that I haven't covered so well, which I'll cover now, will be the how to convert this back into the index. So then the way you go about doing that is you would just take your index in the merge data frame where it's invalid. So let's call this the invalid index. Obviously, we know in this case that actually there'll be no entries. Then we'll take the invalid index over that, index it back into your original index to get the right values, and then make sure that you just take the unique values. So in this case, because I've chosen exactly the same data, it'll be empty. But if there were locations where this was true, you would see that it would show as not empty. Yeah, and I mean this is actually overall a simpler concept. As long as you remember these steps, remember to track the index, remember to think about the kind of join you're doing, think about whether it's many to many or many to one, and the implications of that for the work you're doing. You should get this. I think in general the best thing with this work might be to play about like I'm doing here in a normal REPL where you can run the code and see the outputs and get a feeling for how stuff meshes together before you jump in and start writing rules. Because it can be a bit harder to get a sense of what's going on behind the scenes when you're doing lots of merging or even grouping, and not being able to kind of capture those interim outputs. So I mean this is focused on kind of this year and last year, but there's also plenty of rules that are just to do with saying, okay, like, you know, if this child has adoption data, they shouldn't have OC3 data, for example. And that rule has actually been completed recently by one of the analysts. So what I can do is I can actually talk you through this rule. So it's error code 134 if returning OC3 data for child and adoption information was not be completed. And this requires a join between AD1, which is the adoption data, and OC3, which is the outcomes data for the child. And if you sort of have a look at their code here, you can see that they've written the same kind of thing. So they pulled out OC3 and AD1. They've then merged the AD1 data with the OC3 data. Bear in mind this is meant to be data on adoption should not be entered for the OC3 cohort. So the affected field is the AD1 fields, not the OC3 fields. And then once you've merged this, you know that all data has all the OC3 fields and also all the AD1 fields. So you can access both of these. In this particular case, because AD1 and OC3 should have the same, this merged data frame should be the same length, because OC3 there's only one entry per child. You can reuse the index for this all data in the same way that you would for the original AD1 table without causing any issues. However, this is a bit of a special case, so I still would encourage you to use the reset index approach where possible. The other thing that I would flag from our sort of past pull requests, and good work everyone who's watching this on getting to this point where we are doing some really serious work, is there's a few better ways to kind of write tests for this kind of work. So you can see here, so this is a much more kind of complex rule about checking the dates of the next episode following the previous episode that was written by another one of our analysts. And the way the tests are laid out here is a bit more kind of verbose than kind of the way we have been doing before, which is having a dict of where the key is the name and then a list of values. But it's much easier to read. And also, I think when you're trying to figure out if your rule is doing all the things it should be, it's much easier to sort of see what's going on when everything's laid out like this, where you're able to see each individual line. They're roughly in like column form, and I can quickly see like, okay, so this one fails, this one fails. You probably find that with the more complex rules, you are having to write more complex tests to make sure that everything's good. And I think having a format like this in mind, particularly when you're playing about with the group buys and you want to test some multiple groups, make sure that it works for different children who have different issues. This is a really good piece of inspiration to look at. And in general, I would look at lots of the closed pull requests for the various different bits that you might find interesting to look at. Cool. I think again, quick crash course here. I'll be linking back to all the pandas material on this, where you can think about this in much more detail. And I really would encourage you to play about with this a bit and like try and understand what the different inputs and outputs are going to look like. And once you've written a few simple rules and you're familiar with that workflow, feel free to jump in and start having a go at some advanced ones. So that and throw more questions my way. Good luck, guys.